Greetings and welcome to another installment of Easy SPSS. I'm Dr. Gross, and today we'll walk you through how to run Kendall's tau. It's a non-parametric test that again measures the strength and direction of a monotonic relationship between two ordinal variables. Now, last video we did the Spearman's row. So why Kendall's tau instead of Spearman's row? Kendall's tau is better at dealing with ordinal variables, our categories, right? Low, moderate, high exercise levels, for example, but specifically when there's ties. So many participants might have fallen into the high exercise category, so they tied. Kendall's tau accounts for these ties in a better way than Spearman's row, a more appropriate way. So while Spearman's row is a correlational test that measures a monotonic relationship, Kendall's tau is more robust when it comes to a small sample size, or again, like I said, when the data has tied ranks. There are other non-parametric tests for categorical data, like the chi-square, but you might use that, or you would use that when you have categories that don't assume a natural order, like first, second, third place. So this would be good for M&M color. It doesn't differ by packaging type or something like that. But for our case, where our ranks do assume a natural order, Kendall's tau is the more appropriate choice, especially if there are ties. Again, a monotonic relationship is one that as one variable increases, the other either increases or decreases at a consistent in a consistent way. But it doesn't necessarily have to be linear. It could be curvilinear or a curved line or graphed and represented as one. So for example, exercise level, as it increases, diet type might also change in a consistent way, but not necessarily having to be linear. So we'll again analyze ordinal data in this video as we did with the Spearman's row video. And real quick, these data, they assume a natural order. So exercise level could be low, moderate, or high levels, and similarly low, balanced, or high calorie diets. Again, they have a rank order, a natural order, but we don't know the differences. Maybe this is 900 calories and this is 3,000, but we don't know the difference, which makes this non-parametric test good for this analysis. And so a little bit deeper on Kendall's tau, non-parametric, again, correlational tests. And since it's correlational, we're interpreting it in the same way. So values closer to positive or negative 1 indicate strong relationships, and closer to 0 indicates weaker relationships. And again, measuring that monotonic relationship between those ordinal variables. You would use Pearson's R, a correlational test, for normally distributed data, or data that meets those assumptions that are required by these parametric tests. But tau B doesn't necessarily have to assume normal data or data that is distributed normally, making it a non-parametric test. Specifically, again, this is good for when there are ties in the data, so two or more values are the same. So let's run the analysis. And I'll walk you through it step by step. We're going to use exercise level and diet type, just like we did before for Spearman's row. And I believe we got negative 0.9 something for Spearman's row. So let's see if this correlational test, tau, Kendall's tau, gives us a similar correlation, strength and direction wise. Now accounting for these ties that we have in the data. And I can show you in data view. Here's our data set. I can toggle over value labels. And when I click it, I can see that a lot of these participants When we look at diet type, um, there are ties in these ranks. So all the ones for these participants. So steps to I got sidetracked. Steps to run. We're gonna open the data set, which you would do here, your saved data set. I've already got mine open. And these are the variables that we've been working with in this video series. And we'll go up to analyze, again to correlate, and just like the last video, again to bivariate. When the bivariate correlations dialog box opens up, you will move, and I can move these back real quick. You'll move exercise and level and diet type. I still haven't fixed that. It should say level, missing out. So we're going to move these exercise level and diet type over to the variables box. I can drag and drop. I can click it over. I can control select multiples at the same time. I want to make sure that Kendall's tau is checked. The test of significance needs to be checked for a two-tailed test. And I always like to flag significant correlations, but this is automatically checked for me. So once you have those variables moved over and the right things clicked, we'll go ahead and click OK to run the analysis. So let's interpret this output. If you look over, you can see a correlation matrix table. And this is going to show the relationship between our two variables. And if we look, we can see that for Kendall's tau, diet type is correlated with itself perfectly, but with exercise amount equal to negative 0.886, or we could round and say negative 0.89. And so that is a very strong, again, not, maybe not very strong, but definitely strong negative monotonic relationship between our variables, exercise level and diet type. And so how you would interpret that is you would say that as exercise level increases from low to high, diet type tends to decrease from a high calorie diet to a more balanced or even a low calorie diet, but in a consistent manner. It's pretty close to -1. And so that's strong. In other words, as exercise level is increasing, you could be fairly confident that people are switching from high calorie to more balanced or low calorie diets based on this data set. Our level of significance, two-tailed, is significant at the less than 0.001 level, which gives us a great deal of confidence that these results were not due to chance, but are actually related to our variables in question. Finally, N would represent our sample size at 32 participants. And so summarizing this, Kendall's tau is measuring a monotonic relationship, whereas one variable increases, the other either increases or decreases in a consistent way, but it doesn't necessarily have to be a straight line. It could be curvilinear. Measuring that relationship between, for today's purposes, exercise level and diet type, two ordinal, categorical, but natural kind of order variables. Our tau b value was negative 0.886, strong negative monotonic relationship, and the p-value less than 0.001. So definitely statistically significant. All we needed was less than 0.05 to reach that level of statistical significance. And so what does it all mean? Again, as one's exercise level, according to this data set, increases, diet type tends to decrease to a moderate or low diet type pretty consistently across the data or across the data set. So people who engage in higher levels of exercise are more likely to follow these types of diets, as people with lower exercise levels tend to follow these types of diets in this data set. Again, Kendall's tau, great for ordinal data, especially when there are ties in the data. And there were definitely ties, as we pointed out, in our data view. Well, I hope you enjoyed today's tutorial on Kendall's tau, this non-parametric test when the data is not normally distributed, but you want to find a correlation if it exists. Are these two variables related? Kendall's tau, especially when you have ties in the data. Thanks for tuning in. Next time we will cover a different test in SPSS. I'm Dr. Gross, signing out.